Hi everybody, today we're going to be talking about exponential and logarithmic forms. So it's two different ways to write the same thing. One is the exponential function that we've already seen. The second way we're going to basically be viewing the same thing, but in terms of logarithms. So it's a big word, it sounds scary, but it's actually not all that bad. We're taking the same things that we have and we're just going to basically put them in a different order. So let's start off with what we already have. We already have functions that look like this. Something to the variable power. And b is a number here to be really clear. So like this would be something like 2, 4, anything along those lines. And that would be our variable here. So we've worked with this quite a bit. And what we get to do today is actually rearrange these things. So that's exponential form. What we're going to be doing next is our logarithmic form, commonly called logs, but logarithm is the full way that we would write that out. So what we do for this is now the exponent is the answer. So x and y have switched. We write log for logarithm. Our base is our b, whatever number is there. And then our answer, or the log of b, is y. So this is just a really fancy way of kind of rearranging some of our terms. So again, if we want to directly trace this down, there's our base. It's now a small letter next to the log. Our original y value or answer is now what goes inside the log. And then the exponent is now what goes on the other side. So if we were to take something that we, had been doing last week, like y equals 2 to the x power, what this would now turn into is we'd, again, follow those same steps. So we'd plug in x for x. Our base b is now 2, and then our y value is still just y. So we have our exponential form, and now we have our logarithmic form. So that's the vocab, that's our definition to start. Logarithm is just quite literally the base, and then the exponent, and then the answer just rearranged in a different order. So hopefully that color coding helps you a little bit, and that's basically what we're going to be doing here. So a lot of times for these, it's a value that your calculator is able to compute for you, so you might not even have any variables. So you might have something like 2 squared equals 4 in exponential form, and they might ask you to write the log of this. So the same steps still apply here. So our answer is in blue. Our base is still going to be in red. And then the exponent here, let me make sure I did this right. Here, I messed that up. But we can do it in the same order. It doesn't matter what the colors are. So we'll do something like this. So the log of this is going to be, and you can ignore what I did up top there, we're just going to rewrite these just like we were doing before. So log our base is 2, so I can even write that in red here. Our answer goes here in 4, and then the exponent goes on the outside. So 2 equals log base 2 of 4. So that's how we go from exponential form to logarithmic form. Now it might also ask you to go the other way around. So maybe you have something like log base 10 of 100 equals 2. And what you're going to have to do is rearrange this so that all of those things match again. So let's color code this. Just doing random colors here again, so we can tell what goes where. So our base is 10. Our exponent is outside, and then our answer is the base of that logarithm. And if you look at that, that's actually a true statement. So that was a true log. 10 squared does equal 100. So again, we can go back and forth between logarithmic and exponential forms. I'm going to do one more of these. So we've done 2 examples. Let's do a third. That way we can have, again, it's totally new skill here, a little bit of extra practice. 3 to the negative 4th equals 1 over 81. Base exponent answer. So instead of colors, we can do words this time. So log to our base of our answer equals our exponent. So again, we're kind of putting it in that order, and I think when it's written out like this, it's a lot easier to see because you can actually plug in the numbers and see if what you did was right. It's like log base 3, it's like 3 to the negative 4th. Well, 3 to the 4th does get us 81, so then that would be negative 4th would be 1 over 81. And if you do that, you'll be in good shape. So the next few questions are going to ask you to basically take some exponential or logarithmic functions and change them back and forth. So go ahead, get started on those questions, and then come back in for